Have you ever thought about like a secret code underlying the universe?
Interesting.
Well, today we're diving into this mathematical sequence
Oh, okay.
that's basically everywhere. We're talking nature, art, even the tech we use like every single day. You ready to decode the Fibonacci sequence?
Sure, let's do it.
You know, the one where like each number is the sum of the two before it?
Right, right.
Like 1, 1, 2, 3, 5, 8, and so on.
Yeah, what's fascinating is this sequence was kind of introduced to the Western world way back in 1202
Wow, that's a long time ago.
by Leonardo Fibonacci, no less. It was through a rabbit population problem.
A rabbit population problem.
Yep, in his book Liber Abaci.
Rabbit populations. I wasn't expecting that. What's the story?
So Fibonacci asked, like, if you have a pair of rabbits that can, reproduce after a couple of months, and each month they produce another pair, how many pairs would you have after a year?
Okay, okay.
Assuming, of course, none of them die.
So like a rabbit explosion.
Exactly. Exponential rabbit explosion.
But how does that become the Fibonacci sequence?
Well, as you track the rabbit population, like month by month, you get 1, 1, 2, 3, 5, 8.
Oh, I see it now.
One pair, then another, then they have babies, and, well, you get the picture.
Right, right. So it's like a simplified model.
Yeah, but it elegantly illustrates the sequence.
In a real-world scenario, that is. This is a much cooler origin story than I imagined.
Right.
But you're telling me there's more to this than just runaway rabbits.
Oh, absolutely.
You mentioned like a connection to nature.
Yes, that's where it gets really interesting. The Fibonacci sequence is like deeply connected to something called the golden ratio.
The golden ratio.
It's approximately 1.618
Okay,
and often symbolized by the Greek letter phi.
I see.
When you divide like any larger Fibonacci number by the smaller one before it, the answer gets closer and closer to this golden ratio. The further you go down the sequence, the closer you get.
So that's the mathematical link, but what does the golden ratio actually mean in the real world?
Well, it's considered, incredibly aesthetically pleasing.
Aesthetically pleasing.
And is found throughout nature.
Oh.
In the most unexpected places.
Like what?
The spiral arrangement of seeds in a sunflower.
A sunflower.
The way a nautilus shell curls.
Wow.
Even the structure of DNA molecules.
Really?
They all exhibit the golden ratio.
You're saying this mathematical sequence found in a rabbit problem is like somehow related to DNA?
It is. It's mind-blowing.
That's pretty amazing.
Yeah, it is.
But hold on. If it's about aesthetics, does that mean we see the golden ratio in art and architecture too?
Exactly. The Egyptians supposedly used it in the pyramids.
No way.
And you can see it reflected in the proportions of the Louvre Museum in Paris.
The Louvre.
The idea is that because it's so prevalent in nature, it's inherently pleasing to the human eye.
That makes sense.
Making it a powerful tool.
For artists and architects. Wow. I had no idea there was so much to this Fibonacci sequence. We've gone from rabbits to pyramids already. But before we jump ahead, are there any other cool mathematical tricks
Oh, are there ever?
this sequence has up its sleeve?
The Fibonacci sequence is full of mathematical properties.
Okay.
Like one of the most striking is the square sum rule.
The square sum rule. Okay.
It states that if you take the squares of consecutive Fibonacci numbers and add them up, it equals the product of the nth Fibonacci number and the n+1th number.
Okay, I'll admit that sounds a bit complicated. Can you, like, break that down?
Of course.
Maybe an example.
Sure. Let's take the first 5 Fibonacci numbers, 1, 1, 2, 3, and 5.
Okay, so far so good.
If we square each of those and add them together, so 1 ball plus 1 anota plus 2 ball plus 3 ball plus 5 ball, we get 40.
Okay.
And 40 also happens to be the product of 5,
5.
the 5th Fibonacci number,
Right.
and 8,
8.
the 6th, you see.
That's fascinating. It's like these numbers have, like, these hidden relationships
They do.
woven right into them.
That's just the beginning. There are also patterns of divisibility within the sequence.
Divisibility.
Like every third number is divisible by 2, every fourth by 3, every fifth by 5, and so on.
So it's not just about the numbers themselves.
Right.
It's about the relationships between them. It's like a whole secret language hidden within this sequence.
Yeah, you could say that. And, this language turns out to have applications in a pretty surprising field.
Oh.
Computer science.
Now that you mention it, you did say something about that earlier.
Mm-hmm.
It seems like a huge leap. How can something as seemingly simple as this sequence have applications in something as, well, complex as computer science.
That's what makes the Fibonacci sequence, well, so fundamental and versatile. It's used in computer science to teach recursion and dynamic programming.
Okay.
These are two different approaches to solving problems, and the Fibonacci sequence provides a clear illustration
Of their,
advantages and disadvantages.
could you maybe help me understand those concepts a bit more?
Of course.
Like, what are recursion and dynamic programming?
So imagine recursion as a function that calls itself within its definition, like a set of Russian nesting dolls.
Okay, I can kind of see that.
To get the nth Fibonacci number, you add the n1th and n2th numbers. It works, but it can be computationally expensive, you know?
Because it,
You end up recalculating values.
I see.
That's where dynamic programming comes in.
Dynamic programming.
It basically optimizes. It says, we're going to encounter the same calculations multiple times.
Okay.
So let's store those results and reuse them.
Yeah.
It's much more efficient, especially with larger Fibonacci numbers.
So dynamic programming is like remembering the answers so you don't have to do the same work over and over again.
Exactly.
Like when I try to remember a complicated password, I write it down.
Right. So you don't have to figure it out every time.
But how does that work with the Fibonacci sequence?
Well, this efficiency has real-world impact. Think of how quickly your phone can load images. Or your computer searches through millions of files.
That's true.
All thanks to, well, smart algorithms like this.
That makes a lot of sense.
Yeah, it's all about being, smart and efficient with your calculations.
I'm guessing there's more to the computer science connection than just these two concepts, right?
You are absolutely correct. There's fast matrix exponentiation,
Fast matrix exponentiation.
which uses matrices to calculate Fibonacci numbers super efficiently. Let's say you want to find the 1000th Fibonacci number.
The 1000th.
You don't have to calculate every single number before it with this method.
Wow.
It blends linear algebra and computer science beautifully.
So even though it seems simple on the surface,
Yeah,
this sequence has some serious computational power.
it does.
But I can't help but feel there's even more to uncover.
There is.
You mentioned cryptography,
Yep.
pseudorandom number generation,
Mm-hmm.
and something about a golden spiral.
You're absolutely right. The Fibonacci sequence, or rather the golden ratio derived from it, has a visual representation.
Okay.
It's called the golden spiral.
The golden spiral.
Picture arranging squares with sides that correspond to Fibonacci numbers. 1, 1, 2, 3, 5, and so on.
Got it.
Draw quarter circle arcs within each square, and, well, they connect
Okay.
to form a beautiful spiraling curve.
So we're talking about a spiral that's literally built from the Fibonacci sequence.
Precisely. And this isn't just a mathematical abstraction. The golden spiral, appears everywhere in nature,
Right.
in the spiral arms of galaxies, the shape of hurricanes, even the way some plants grow.
So it's like the Fibonacci sequence is this sort of universal design principle.
It really is a testament to the interconnectedness of math and, well, the natural world.
This is truly mind-blowing.
Right. It is pretty amazing.
But I gotta ask, how did ancient civilizations know about any of this?
That's the question. We're not entirely sure how they, arrived at these insights. That's interesting.
Perhaps through observation, intuition, recognizing patterns in nature,
Okay.
and then, incorporating them into their art and architecture.
It's incredible to think they grasped these concepts
I know.
without our modern tools and technology.
It really is.
It really highlights the power of observation and human ingenuity.
For sure.
But there's still one burning question in my mind. Why?
Why?
Why is this sequence and the golden ratio so prevalent in the universe? Is there a deeper reason? Or is it just a happy coincidence?
That's the million-dollar question.
Right.
There are many theories, but unfortunately no definitive answers.
I figured.
Some believe it represents an efficient growth pattern in plants, ensuring optimal sunlight. Others see it as an example of, complex systems theory, simple rules giving rise to intricate, seemingly complex patterns.
So is it nature's way of, optimizing for growth and survival?
Or something even more profound, like a fundamental principle woven into the fabric of reality.
That's the beauty of it. We're still trying to figure it out. The Fibonacci sequence continues to, intrigue and inspire us, pushing us to explore those hidden connections and patterns governing our universe.
know.
And you know what? This is really just the tip of the iceberg.
It's amazing to think we've only, like, just scratched the surface.
Whoa, right?
I'm already reevaluating everything I thought I knew about math.
It's pretty mind-blowing stuff.
You mentioned there's even more to explore with the Fibonacci sequence, like in fields like quantum physics and cosmology.
Yeah.
Now we're talking about the really big stuff and the really small stuff. How does Fibonacci fit into those areas?
Well, physicists are starting to investigate what they call, quantum Fibonacci.
Quantum Fibonacci?
Yeah, looking for those familiar patterns in, well, quantum systems.
Okay.
It's early days, but it has the potential,
Good
to
to-
lead to breakthroughs in quantum computing.
Right.
And cryptography.
So imagine a world where our computers are exponentially more powerful
Exactly.
and our data is, like, even more secure.
All thanks to this ancient sequence.
That's incredible. So even in the mind-boggling realm of quantum mechanics,
Yeah.
the Fibonacci sequence might hold the keys to unlocking new technologies.
It very well might.
And what about cosmology?
Yeah.
You hinted that the structure of the universe itself might be influenced by the Fibonacci sequence.
There are some pretty mind-bending theories out there
Really?
suggesting that the Fibonacci sequence could be, influencing the distribution of galaxies, the formation of stars,
Wow.
even the expansion of space-time.
Really?
It's still, very speculative.
Sure.
But the idea that this seemingly simple sequence could be woven into the very fabric of the universe.
Right.
It's fascinating, isn't it?
It's definitely making me question everything I thought I knew about the universe.
Mm.
Okay, let's come back down to Earth for a moment. You mentioned earlier that some financial analysts use the golden ratio.
I did.
How does that work?
Some traders use a technique called Fibonacci retracement
Fibonacci retracement.
to try and predict stock market trends.
Okay,
They look for points where a stock price has, pulled back from a recent high or low,
right.
and use Fibonacci ratios to identify potential support and resistance levels.
So they're using this ancient mathematical concept to try to make sense of the often, well, chaotic stock market.
That's one way to put it.
That's both brilliant and a little bit terrifying. But does it actually work?
And that's a question that sparks a lot of debate. Some traders believe strongly in Fibonacci retracement, while others are much more skeptical.
I can see that.
There's no guarantee, obviously, that it predicts the future of the stock market,
Oh,
but it does, provide a framework for analyzing price movements and identifying, potential turning points.
So it sounds like another example of how the Fibonacci sequence helps us find patterns and try to make sense of complex systems, even if it doesn't, well, provide all the answers.
Right.
You also mentioned one more area where the Fibonacci sequence is being applied, artificial intelligence.
Yeah, it's pretty exciting stuff.
How does that work?
Researchers are experimenting with using the Fibonacci sequence to optimize the structure of neural networks.
Neural networks.
Yeah, which are the foundation of many AI systems.
Right.
It's still, a relatively new field.
Yeah.
But the idea is that incorporating Fibonacci proportions into the design of these networks might, help them learn more efficiently and process information more effectively.
So we could potentially use this ancient sequence to help, like, build the brains of the future.
In a way, yeah.
That's both exciting and a little, well, unsettling, to be honest.
I understand that.
But it speaks to the enduring power of this mathematical concept. It seems like everywhere we look, from the smallest particles to the vastness of space, the Fibonacci sequence is there, shaping our understanding of the world.
And that's what makes it so, fascinating. This seemingly simple sequence, first introduced through a problem about rabbit populations,
Right.
has turned out to have profound implications: math, science, art, and even, philosophy.
Wow.
It challenges us to look for patterns, to seek connections,
Right.
and to, wonder at the underlying order of the universe.
When we started this deep dive, I never imagined we'd be talking about quantum physics, cosmology, and the secrets of the universe. But that's the beauty of a deep dive.
It is. It takes you to unexpected places.
I want to circle back to the golden spiral, though. We talked about how it appears in nature,
We did.
but you also mentioned art and design.
Yes.
Can you give us some concrete examples?
Of course. One of the most famous examples is Leonardo da Vinci's Mona Lisa.
The Mona Lisa.
The composition of that painting is believed to be based on, the golden ratio and the golden spiral,
Okay.
contributing to its enduring appeal.
I see.
You'll also find similar principles at play in the Parthenon in Greece, the Taj Mahal in India, and, countless other architectural marvels.
So this spiral isn't just a mathematical curiosity.
Right.
It's been actively used by artists and architects for centuries
Yes.
to create, well, works of lasting beauty and impact.
Exactly. And it's not limited to the classics.
Oh.
Modern designers and photographers use the golden spiral to compose images, create logos, and even lay out websites.
Really?
It's a testament to the enduring power of this principle to, influence our sense of aesthetics.
We may not even realize it,
I know, right?
but we're like surrounded by the golden spiral.
Yeah.
But it does make you wonder, are we subconsciously drawn to these proportions? Because they're so prevalent in nature?
Yeah.
Or is it something, we've learned to appreciate through cultural influences?
That's a great question.
Right.
It gets to the heart of the debate surrounding the golden ratio.
Yeah.
Is it a truly, objective measure of beauty, or is it a cultural construct?
Interesting.
Perhaps maybe it's a bit of both.
Yeah, I could see that.
Think about it.
Yeah.
How much of what we consider beautiful is influenced by our, biology,
Right.
and how much is shaped by our cultural upbringing?
That's such an interesting thought.
It is.
It's fascinating to consider how much of our perception
Yeah.
is shaped by factors we may not even be aware of.
Absolutely.
But whether it's innate or learned, there's no denying the impact the golden ratio has had on, art and design throughout history.
For sure.
And it all comes back to this incredible sequence.
The Fibonacci sequence.
It's like a hidden code
Yeah.
that unlocks beauty and order in the universe.
It reminds us that math isn't just about, abstract equations and formulas.
Right.
It's a language that describes the very fabric of reality. And sometimes the most profound truths
Yeah.
are revealed in the simplest of patterns.
I have to admit, I'm feeling a bit overwhelmed by all this information.
It is a lot to take in.
When we started this deep dive, I had no idea we'd be talking about quantum physics, cosmology, and the very essence of beauty.
I hear you.
But that's the power of a deep dive, right? It takes you to unexpected places.
It does. It's all about embracing curiosity,
Right.
following the threads of knowledge,
Okay.
and, always being open to new perspectives.
That's a great way to put it.
And with a topic like the Fibonacci sequence, those threads, they seem to lead everywhere.
They really do.
We've covered so much ground today, from the origins of the Fibonacci sequence to its applications in art, science, and technology. We've seen how it connects us to the natural world, and even how it might hold clues to the mysteries of the cosmos.
It's been an incredible journey.
It has.
What stands out to you from our conversation today?
That's a good question.
What are your biggest takeaways?
I think for me, it's the sheer interconnectedness of it all.
The interconnectedness.
The way this simple sequence derived from a problem about rabbits pops up in fields as diverse as, botany, astronomy, and computer science. It suggests a fundamental order and harmony in the universe,
Yeah.
a sense that, everything is connected in ways we're only beginning to understand.
That interconnectedness is truly awe-inspiring.
It is. It makes you realize that we're, part of something much larger than ourselves,
Yes.
connected to everything in the universe through these underlying patterns and principles.
It's both humbling and inspiring.
It is.
And it makes me want to keep exploring,
Sir.
to keep looking for those hidden connections and patterns.
Absolutely.
We've explored the history, the math, the science, and even a bit of the philosophy behind this extraordinary sequence.
I think it's time to leave our listeners with a final thought to ponder,
Okay.
something to spark their own explorations.
I like it.
We've discussed all the places where the Fibonacci sequence appears,
Right.
but what about where it doesn't appear?
That's an interesting thought.
Are there places where this pattern breaks down, where chaos, reigns supreme, or is it woven into the very essence of reality waiting to be discovered in every corner of the universe?
Yeah, that's a fascinating question to think about.
It really is.
That makes you wonder, like, what else is out there?
Exactly. It really makes you, rethink your assumptions about the world.
We've given our listeners a lot to ponder today.
We have a lot to digest.
I hope it encourages them to, like, see the world with new eyes.
Me too. Maybe they'll start, noticing Fibonacci spirals in unexpected places.
Yeah, like the arrangement of petals on a flower, or the curve of a seashell.
Or the way a vine curls around a branch.
Oh, that's a good one.
There are just, endless examples out there.
I think that's what I love most about the Fibonacci sequence.
What's that?
It's not like a closed book.
Yeah.
It's more like an open invitation.
To keep exploring.
Exactly. To keep asking questions.
And pushing the boundaries of, our knowledge.
Exactly. And who knows, maybe one of our listeners will make the next big Fibonacci breakthrough.
Wouldn't that be something?
They might discover a new application, a new connection, a new insight that changes the way we see the world.
It's definitely possible.
So to all our listeners out there, we challenge you. Keep your eyes open, your mind's curious.
Yeah, keep those minds curious.
And don't be afraid to explore the world around you with a fresh perspective.
Because you never know. You might just stumble upon, the next great scientific discovery.
Or a beautiful work of art.
Or even just a deeper appreciation for the interconnectedness of everything.
And if you do, if you do stumble upon something extraordinary, share it with the world.
Please do.
Because the beauty of knowledge is that it's meant to be shared.
To be built upon.
To be expanded.
To inspire others.
Well said. I think that's the perfect note to end on.
I agree.
Until next time, keep diving deep.
Keep seeking knowledge.
And keep those minds curious.
And never forget the power of a simple sequence to unlock the mysteries of the universe